welcome back. For today, we start reviewing design patterns in the previous lecture. We review quickly the fundamentals for the first of the patterns that we're reviewing, the observer. Hopefully you have the opportunity to review the class diagram, the source code, and have the global idea of how the pattern works. Previously, we review the categories. We are working here. We're talking about the behavioral patterns. In particular, we're talking about this one. Something that we review about that one is the problem that we solve. We have two classes. They need to share data. So the class that have the data is the observable. The class that want to know the data, that want to be informed about the changes of those data is the observer. We review different examples, including the listeners. We talk about how a listener and an observer are the same idea, but Java called listeners, the observers that are related with events, with the widgets in a graphical user interface. We talk about this, we review the class diagram, we transform the class diagram to the implementation. I use a lot this idea of the Pac-Man and the Pac-Man as a subject and the ghost of the observer of the Pac-Man. Anyway, moving forward, the implementation of the observer using the Java API. What happened here? Basically, instead of implementing 4 classes, you can use the Java API, and this one are already there. So you only need to worry about these 2. And you only need to worry about this connection, and this connection, the inheritance and the connection between your classes. This connection here already exists in the libraries. So you get all this part done in the Java API. How that work? Let's check one example and then we can do an exercise. For the example, we start working with this idea previously in which, well, I want a student. I'm going to create this class. And I want a tutor or a professor. And they are going to be 2 objects in a classroom. This guy should be an observer, should be observing the tutor. The tutor is going to be the observable, the subject. These are the names that you are going to have in the Java API. We talk about it, subject in the template, the default. Java, instead of a class subject, Java is going to create this class observable. So observer and observable in the Java API. For the Java API, those 2 classes are going to be in the same package. The package, the Java util. You are going to have the class observable in Java util. You are going to have the class observer in Java util. When you want to use observer pattern, the only thing that you need is to include those imports in your programs. And with that, you get access to these 2 classes. Now, moving forward, I want this one and this one, my classes. Starting with the student, the first thing that I want is to a student to be an observer. Using the Java API, step number 1, to create an observer. In Java, implement observer. Why implement, not extend? Because observer in the Java API is an interface. From the interfaces, you use implements instead of extend. Java API, observer, observer is going to be an interface. Do you remember what do we have inside of observer? If you remember, the only thing that we have inside of observer is the signature of one method, the signature for the method update. There is no variables. There is no methods with bodies. It's just observer, the block, and inside this empty method update. In the original pattern, it's an abstract class. In Java, they transform to an interface. It's a class without variables and with only one method, and the method is empty. It's a perfect candidate for an interface. Observer is an interface. And if you remember, when you implement an interface, something that you should do is to provide a body for all the methods in the interface. The interface observer have a method. The method update. Something that you should do is to override that method. This look familiar? Do you remember what do you do when you use listeners? Do you remember that if this one is action listener, what you do is to override the method action perform? Or if that one is a mouse listener, you override a set of methods that are related with the clicks of the mouse, and so on. Every single time that you do the implementation of a listener, your class should have some particular methods. I can implement observer, my class is going to have a particular method, the update. Now, a big difference between the Java implementation and the original template. What is this? What I am receiving as a parameter in the method update. Is an object, an observable object, correct. Why? Think about it. I am an observer. You are the subjects, the observables. And you are the ones that are going to tell me that you did something that I need to be aware of. So you are going to call my method update. But just because I can have several subjects, several observables, in order to know which one call my method update, something that I am going to receive as a parameter is a reference to you, to the one that is calling me. Did you notice the power of this is you have something that is an observer taking care of different objects here, and the object, when this one change something or do something important, is going to notify this one, but it's going to send as a parameter a reference to itself. So I will know who is calling me. I can establish a communication. In this particular example, I am going to receive this parameter, O, and something that I can do with O is to call a method. Call a method and ask that one, okay, you call my method update because you did something important. Now tell me what you did. In particular here, get me the question. Assuming that I am a student, so I am being called by the professor. Now I am going to communicate with the professor and I am going to ask the professor, okay, which was the question? Bidirectional communication. If you remember in the original template, this one was an arrow like that. For the Java implementation, the connection between these two is just a line without the arrows. Why? This one is going to call a method here, but also the opposite is going to happen. This is still observer. This one obviously is not a solid line because now this one is an interface. It's still the observer. Now with interfaces, now with bidirectional communication, just because it's a good idea. The observer and the observable, and they are going to talk. I am doing something important. Tell me more about it. 2 lines. Good. So my student and the general rule, any class that you want to observe, to receive data from another class, step number 1, step number 2. That is what you need to do. And using this reference, you can get more information. You can get 1 variable or more, a collection maybe, whatever you need from the source. 1 steps, 2 steps. Remember those 2. Yeah, we mentioned that, or I am going to mention that later. The class in Java is depreciated, the class observer and observable. The recommendation that they do is to use this property change listener. That is the recommendation of replacing the observer and observable. The only reason because they do that is because the original implementation of observer observable do not work with multi-threading, do not cover multi-threading, do not include anything related with synchronizing multiple access from different threads. So they decide to depreciate it. You still can use it. If you are not working with multiple threads, it's going to work. So you can ignore the depreciated message. Good. But if you are doing something with multi-threading, you remember property change listener observer. Good. So next, that was the student, the observer. What about the observable? If you have a class and that class have information and you want that information to be accessed by others, by observers, what you need to do, the following. Notice that observable use extends. Why? It's a class. Observable is a class. Why? Why observer can be an interface and why they need to have observable as a class. Do you remember the content of the observable subject class? What is the problem? Why I cannot change that one to an interface? Do you remember what is inside of the observable? Number 1, the important thing, a variable, an attribute. A data structure, remember? This linked list in which if I am an observable, I am a tutor, and I know that there are several students observing me, I need to remember them because I am going to notify all of them that I did something important. There is a data structure, a variable in the class observable. And also, because I have the data structure, I have methods add, remove. Do you remember? Add listener, remove listener, or in this case, it's going to be add observer, remove observer. And those methods have a body because add observer or remove observer, I can put the instructions there to access the data structure and add or remove something. So I have those. And also I have some method notify that is a traversal from the beginning to the end of the list. I have variables and I have methods, and the methods have instructions. I cannot have in an interface variables and methods that have a body. The interfaces are for methods without bodies. According with this description, to have the variable, to have those methods, I need a class. This one should be a class in the library. And therefore, I need to use extend, inheritance from classes. Good. You do the extend, and automatically your class is going to have this data structure for remembering the observers, and it's going to have those methods for adding and removing, and it's going to have this method notify that you can call. The only thing that you need to do in your class, like this one, is to call the method notify, the method that you are inheriting. Where are you going to call the method notify? In any place in which you do something that you want your observers to be aware of. For this example, I have this method ask question, and I want to notify my observers every time that I, as a tutor, ask a question. The only thing that I need to do is inside of the body of whatever class is creating information or handling information, in that method or methods, because it could be several, in which something important happened, I call the method notify that I am inheriting. In particular, if I am using the Java API, the full name of the method is going to be notify observers. Add observers, remove observers, notify observers. Moreover, something that happened with the Java API is that you usually call those two. Set change. I did something. Notify observers. Send a message to all the observers. I did something. Send the message. Two methods. Set change, notify. You put those two, the red ones, in any method that is doing something, and after that method finished to do whatever, you want to notify the observers. One, two things in the observer. One, two things for the observable, for the subject. Next, put everything together. The main. In the main, two objects, one student, one tutor. I want to connect them. I want to say that one is observing the other. Add observer. And I just want to be sure that this is clear, that this guy here should be an observer. This guy here should be an observable. Observable, add observer. The observer is the parameter. Two objects from the class student and tutor. Student and tutor are inheriting from observer and observable. And then this line make the connection. After that, whatever I have, such as this method there, that method is going to be calling the method ask question in tutor, and you know what is going to happen. I am going to call 5 times the method ask question, just because tutor do that, tutor ask questions. Internally, Every single time that the ask question is executed, ask question is going to call notify observers. Notify observer is going to call this method update in the observers, and this method update is going to be able to use the object to get the information from the other class, and with the information do whatever the object needs to do. Easy and safe way to connect to classes in which one needs information from the other. Questions? Very simple, right? Let's think about a problem. What if I need a class, a place in a program, and this class I am calling data source. This class somehow is going to collect data, is going to create data. I am going to have two variables. X and Y. And this class have a method. And the only thing that the method do is to put information in those variables, to put numbers in the variables X and Y. Every minute or every 30 seconds, something, the values in those variables change. And I have new values there. Number one, can you program this class? It's a class that is alone. What do I need to program this class? Can I create a class that the only thing to do is to randomly create numbers and store those numbers in two attributes? And hopefully you're thinking like, yeah, looks like trivial. I can have a class. My class can be something like that. You are asking for two variables, and because of the minus, they are private integers, X, Y. Could be a good idea to have a constructor. Well, the only thing that the constructors do is to put the initial value to the variables, right? One method, the method work. And that one is the only method that is going to do something. And you are asking me that method to put data in the variables. Here, this method can be as complex as you need it. This method can do a connection to the cloud and get the data for those variables from some service that is running outside, or maybe it's going to read a sensor connected to your computer, or it's going to establish a connection to a database and the data is going to come from the database. We do not really care. The method is going to get the data from someplace. easy implementation for my example. You want data? You have your data. Version 1 of my system. The X and the Y are random numbers times 100. Later, this can change to something more interesting. There is your data. Now, you want this class or the objects from this class to create data every second or 30 seconds or something like that. You can create a thread with this. So far, my class. Now, you know what? That is good. That is the source of the data. What if I want to put this data on the screen? Moreover, what if I want to have something like just remember your Pac-Man? What if I have this class that is creating data, X and Y, randomly, and I want to have an application and I want to use those values, and in the position X and Y that correspond to those values, I want to draw my Pac-Man, or I want to draw something, whatever, a rectangle. But that rectangle, the position of the rectangle is according with the data that I have in this class. So there is a class that is calculating the values, and I would like to have those values on the screen. Hopefully you agree with me that in order to have the values on the screen, something that I need to do is to create another class. Because hopefully you agree that it's a very bad idea to put everything together in one class. It's not a good design. Two classes. That class is going to create the values. It's going to create the values, and I do not really care about the algorithm that is going to create the values. They are random, good. You're going to change that to something else, good. Is your class. There is going to be one developer working with this class and creating the values, put data in the variables. His problem, her problem, not mine. What I need to do is to put those values on the screen. Put the values on the screen. In order to put the values on the screen, something that I am going to do is to create a new class. Whatever name that I want to use. If I create a new class, there are things that I need to do. Number one, in this class, the blue one, I want to draw something. And after you did your Pac-Man, I am sure that you are aware what I need to do in order to make this class to have the possibility of drawing something. Well, your class should be connected with JPanel, probably. When you do the class diagram for the classes that are in a library, you do not need to put the methods and the variables. Remember, different levels of abstraction. We care about the variables and the methods in our own classes, but for those that are from the library, they can be empty. If someone needs to know about the variables and the methods, that person can go and review the API. The only thing that I need is to establish that I am going to create a new class that new class is going to be able to draw things. And in order to be able to draw things, something that I need is a method, public one. And that method is going to be in component. And hopefully you remember that one because you use with the Pac-Man, with your assignment. That is the only method that is able to draw things. If I follow this idea, my class, the one that is going to be able to draw things, well, that one is going to be a class. That one is going to be Canvas, is the name that I give. That one is going to be extending JPanel. Is something that I need. And so far, that one is going to have this public void. And that one have that parameter, and I can use that parameter to draw a rectangle. The first two parameters for the draw rectangle, the position, the others, the size. Is the only thing that I need. Okay, here is my problem. My problem is that the numbers here, the position for whatever I want to draw, are these two variables. This is the scenario in which I have one class, data source, and I have another class, Canvas, and Canvas need access to the information in data source. What I need to do is to connect this source code with this source code. Hopefully, number one, you notice that this is a scenario in which the observer pattern is the solution. Two classes, one need information from the other. Observer. Okay, I am going to use observer. What do I need to do? According with this, according with the theoretical background that I shared with you, one, which one is going to be the observer and which one is going to be the observable? The observer is going to be data source, or the observable is going to be data source? Ideas, data source, observer or observable? Hopefully you agree. Canvas is the observer. Canvas is the one that needs information from the data source. The data source is the subject, the observable. What is the connection between data source and observable? Implement or extend. Hopefully you agree with me. Inheritance. Inheritance with the solid line. Observable, according with the previous description, is a class. It's the class that have the data structure, the methods, and so on. Inheritance. Okay, inheritance. In your class diagram, something like this. What about the source code? In the source code, two things, remember? Two steps. Step number one, used to accomplish the class diagram, data source. And obviously, Java. What else for data source? Step number 2, what do I need to do? Number 1, I inherit from observable. Okay, now I am a subject, now I am an observable. Step number 2, notified observers. Notified observers, where? In the constructor, in work, in another method? Where in this source code I am doing something important that need to be notified to someone else. And hopefully you agree with me, work. Something important is happening in work. What? The values of the variables are changing. So could be a good idea to notify the observers that the values of those variables are changing. What I need to do in order to notify the observers? Here, inside of the method, after I change the values, the only thing that I add to my source code, those 2 red lines and the inheritance. And what I am doing is allowing other classes to check the values of my variables in data source. You can be thinking, which observers are going to be notified? Whatever observer that express interest in this guy. That is something that I am going to put in the main. For this class, I do not care. I am the data source. I am doing my work in blue. You want to have access to my data? Okay, the only thing that I need to do is to add the things in red. I am going to use inheritance and I am going to call these 2 methods. The 2 methods come from the class that I am inheriting and my work is done. I have no idea who is going to observe my values and what is going to happen with those values. My work, the work of this guy is done. What about the canvas? According with your description, this canvas want to be an observer. An observer, okay, but observer was an interface. Canvas is inheriting from JPanel. Canvas is going to implement observer. And just like that, I do not need to show the methods in the interface. It's a class diagram, it's abstract, but you know, here we have the update, and this guy is going to need update, is going to override the update. Following with this, extend JPanel. Implement observer. Okay, implement observer. I need to override the method from the interface, the update from Java. Receive as a parameter the observable and something else. I don't care about the second one. I care about the first one. This is the one that is going to give me access to the guy that have the information. What I am going to do? Well, what I need is to have here X and Y. And the values for X and Y, somehow I am going to get those values here. I have this X and Y, and there are two methods using X and Y. I need them to be global. Now, let me be clear. The names could be whatever you want. Here, they can be A and B. And my rectangle is going to be in the coordinates A and B. What I need to do is to get the values for A and B. What I do to get the values for A and B? Well, I am going to use this guy, the guy that is the observable. Again, the connection is going to be done in the main. The only thing is, I have a method update. This method is being called every time that the values of the variables change. When I am called, what I need to do is to use that O and get the data. What I do to get the data, it could be a good idea to have a method get X and a method get Y. I just call the method, and whatever those methods return to me are going to be my variables A and B. Okay, so it's a very good idea here in my data source. This guy needs public int get X. Getters and setters, they need to exist, right? Any variable should have the getters and the setters. In this case, I am not using the setters, but I need the getters. More source code for my data source class. Now, this is working. Data source as an observable, the canvas as an observer. The canvas is going to get the information from the data source. The canvas is going to use that information to paint. One last thing that I need to do. Every time that update is called, I get the data, and what I need to do is to show that data on the screen. What I need to do is to call my method paint component. However, something that we know is that in order to call paint component, it is just good enough to call paint. Or if you want, repaint. Receive the information, repaint myself. And the rectangle is going to be drawn in those coordinates. Done. Observer. Now, you could be thinking, okay, yes, you have a programmer doing this, and you have another programmer doing the other one. They did their part, but show me how to put everything together. Okay. What do I need to complete this program? Well, number one, this canvas is a panel, but you can agree with me that we need a frame to put that panel. We need a class main, and probably that class main is going to have your public method main, the one that is going to put everything together. Now, what is going to be the relationship between the class main and my class data source? There is going to be any relationship? If so, which one? Inheritance, composition, aggregation, association. What is the connection between this class main that is going to have the main and data source? Something that hopefully you are thinking about right now is, well, inside of the main, I need to create an object data source. And if I am going to create an object data source inside of the method main, which is the relationship, the arrow that I need to draw between those two classes. Do you need diamonds or not? And hopefully you agree with me. No, it's going to be a local variable. It's going to be a local variable, no diamonds. You're going to create the object used to call the method, use association. Main is connected with data source with that arrow. Okay. What about main with canvas? They are going to be connected. My goal is that main is the window and the canvas, the space that I am using to draw is inside. These two are going to be connected. Another association, or maybe I need a diamond here. I am going to create an object canvas inside of main in some place. Inside of a method, or need to be an attribute? It's going to be global or it's going to be local? Well, you already did the Pac-Man and you already did your assignment. Hopefully you agree with me. This canvas do not need to be global. It's just good enough a local variable. So another case of association. Main is going to be connected with canvas used by association. So far, main do not have any global variable. According with this diagram, everything is local. One extra thing, this main is supposed to be the window, the one that have the frame. I need the class J frame. In particular, the class J frame is going to be the parent of my main. Good. Okay, Professor. The diagram looks good. Show me the source code. A class. Main. Any extend or implement? And hopefully you remember, yeah, you need to do extend and extend from the G frame because this guy is going to be the main window. Okay. What else? Well, there are several objects that we need to create here. I think would be a good idea to have a constructor and we can use the constructor to set up everything. Inside of the constructor, we need a canvas. We need a data source. Those two objects, local variables, are the arrows that I draw between main and data source and canvas. Those arrows, those associations, these two variables. Wait, these two variables, they are one observer and one observable. In fact, in my class diagram, this canvas and this data source, they are or should be connected. Remember, what I have is, and I am going to draw here, observer, inheritance, canvas, observable, inheritance data source, in particular this one with the dash line, and these two are connected. These two are also connected, but because they are in the library, I don't care. You do not show the connection between classes when both are in the library, just to keep your diagram clean. These are the connections that I need to show. The inheritance and implement that I am doing, and the connection between the observer and observable, my canvas and my data source. This is something that is in the diagram above. This connection needs to be done. I have the canvas. And I am going to use this method. I need one parameter here, and I need one object there. Tell me, which one is going to be inside of the parentheses? The canvas, the C, or the data, the data source? Which one is the observer? The canvas. The object that is the observable, the data source. The name of the object is data. Something that I need to do is to call the method add observers. It's a method that I am inheriting. The parameter, the observer. In this case, I have only one observer. The observer is the canvas. I have the canvas, the data source, and now they are connected. Connected in one direction, the other is going to be the get X, get Y that I defined previously. Done. The other thing that I need to do is to complete my program. It could be a good idea to define a layout. It could be a good idea to define a grid, one column, one row. It could be a good idea to add to the frame my canvas. And that instruction are going to put my canvas in the full frame. So I am going to have this canvas using the full frame, and inside of the canvas is going to be this rectangle, and the position of the rectangle correspond to the data that I am creating in the other class. This could be everything that I need in the constructor. The last thing here, I need my public static void main and here my object. You can put some size if you want. But the important thing is make all the full thing visible. That is your program. The important thing, the pattern observer is the one that you use to share information between the functionality of the software and the graphical user interfaces. The communication between graphical user interfaces and the elements in your program in which the information is created is usually an observer pattern, just like we did here. Someone can work in the graphical user interface, someone can work in the functionality, separate things. This example, I have only one canvas observing the data. Can you imagine having not only one, but 4, and all of them drawing exactly the same rectangle in the same position? Can you imagine for, instead of canvas charts or plots, one bars, the other lines, the other pie, 3 different formats of charts, and all of them in the same screen plotting the same data? It's just observing the same source for different observers. Done. One programmer is responsible for each of the plots, for each of the charts, and another one is responsible for the information. That is what you do. Now, one additional thing. The only thing here is everything is working good, but you know what? In my example, something that I didn't do is to include threads. Something that I didn't do is, well, this is going to work. I am observing things, but the source of the information, I didn't include a loop. I didn't include a thread. Can I do that? Can I include multi-threading, just like we did with the Pac-Man, in the source of the information? That is going to work. Yeah, you can do it. It's not related with the observer. It's related with your source of data. One example, and I am going to ask you now to help me, not with the source code, but with the class diagram. What if I show you the following source code? Global idea, an observer, and an observable. Global idea, one source of data, one screen, just like the one that we create. The source code for this. One, I have this class source. Do we understand all the lines here? And hopefully the answer is yes, because it's basically exactly what I did before from scratch. What is this source? Is my class that is creating values for X and Y using this approach of the random. Moreover, is observable, and I am calling set change and notify observers. It's exactly the one that we did before with the getters. If all things here is kind of hard to follow, you have the source code in the slides. A source of information implementing observable. Done. What about this class note taker? Do we understand that this is a panel? Do we understand that that panel is implementing observer? The same thing that I explained before? Do we notice that here we have the update method that corresponds to the observer? And do we have the paint component that corresponds to the panel to draw something? I am using here the draw string instead of the draw rectangle. I am going to print the numbers. And that number, that string, is this one that I am getting with this getX method. I am only getting the X. You can help me to complete this and get the Y also. And the variable. Why the variable? Because I need the variable here and the variable here, right? Note taker, the observer. Source, the data. I need to add the multi-threading. What is happening in this class? It's not related with the pattern. The pattern is already there in the other classes. This is something else. What is this? There is something new here? Something that maybe you remember that we used before in a different way? another class in the Java util package. What is the goal of the class timer task? Before you use timer, what is the goal of timer? Now timer task. To create something that is going to be able to repeat several times in a period of time. My class boss is going to extend this class timer task. And when I extend a class, what I need to do is to provide a particular method. The class timer task is going to ask me to provide a method with the name run. And you know what is going to happen? This method run is going to be executed several times in a configuration that we're going to put in the main. We're going to put in the main how many times in a second, in a minute, we want this method run to be executed. What else is happening here? Well, did you notice that this boss is connected with someone source? Did you notice that this class boss is going to be doing something several times every second or minute or whatever we configure later? And did you notice what we are doing? What this guy is doing is calling the method create. I have this class boss. The class is going to be running a method with the name run every second, minute, or whatever we configure later. And inside of that method, every second, minute, or whatever, what I am doing is to call the method create in this guy that is a source. And you know what happened? That we are going to have observers, other looking to this guy. So if I have one guy asking the other to create something, this is create. If I have another guy asking this one, create several times in a second, what is going to happen is that these ones, the observers, are going to be observing in a second, in a minute, several different values for the variables X and Y. One class is responsible for putting to work the source, and another class is responsible for doing whatever needs to be done with what source is doing. And just like that, I have the observable working, always working, because this thread is asking him to work. And if you're wondering about the main, do we understand the main? There is anything in the main that I do not explain before. There is anything in the main that we haven't done before. We already use JFrame. The class is word, so this one is the constructor. One object, two objects, three objects. I am creating an object node taker, I am creating an object source, and I am creating an object boss. Do we know what is happening in the line 11? By now, it should be like, yeah, you are connecting an observer and an observable. The note taker, this guy, is going to be observing the source. Notice, I have this guy observing this guy, the source, not the boss, the source. Is the one that is creating the numbers. This is the one doing numbers. And this guy is interested in the numbers. These two lines, the note taker is a panel and I am adding that panel to the screen. So basically I am including this guy inside of the window. It's a panel. Okay. We did that before. The new things here is now I have this object that is a boss, innate from timer task. I am going to create this boss. The boss have inside a source, remember? This is the boss, and we put inside of the boss a source. It's like, I am the owner of this guy. I have it, it's mine. I am going to have this guy working for me. Object-oriented programming. Anyway, this boss is going to have this one, the one that is going to be creating numbers as a slave. It's an object inside of the other. Good. I create a timer. A timer is the clock here. And basically I ask the clock to schedule the boss working in this example every second. In milliseconds, every second the boss is going to be working. And remember, this is the work of the boss. The only thing that he's going to be doing is asking the source to work. The work of the boss. Every second, he's going to be pushing this guy to create a new value. And automatically, every time that this guy creates a new value, this guy is observing. And this guy is observing and is drawing something on the screen. So what we're going to have is this clock is controlling the boss, which control the source, which control the note taker. This number is every second we have a new number, and every second something new is drawn on the screen. If we want to change the second and use minutes or something, just change the numbers. And that is going to change this guy and this guy. Your draws are going to be slow or faster, depending on this number here. The rest of the program, the main, a new object word, the size, the visible, and obviously, if you want the close to work, configure the exit. Done. Observer with threads and observers without threads. We reviewed one example in the previous lecture. We reviewed 2 examples today. Moreover, I am giving you an extra example, this one, between the professor and a student with this small graphical user interface with 2 panels. As a homework, review this source code. This source code create this output is another example of observer. So 2 examples today, 1 in the previous lecture, 3 plus this one that I am asking you to review 4 examples of Observer. Observer is in your quiz the next week, is in your exam. Please review this, all the source code, and be sure that you understand what is happening and how the Observer pattern work. Any question, guys? Please, homework and nothing to submit. Review the source code, review what we did today and the previous lecture. Any question, let me know, send me an email. See you next week. Thank you.